Hybrid and electric vehicles for the most part are disabled the same way as conventional vehicles. The shutdown procedures described here will disable the high voltage system and, if equipped, the vehicle's airbags and seatbelt pretensioners. These steps are critical to ensure emergency responder safety. Keep in mind, however, that even after the high voltage system is disabled, the batteries still retain their charge, even if the rest of the circuit is isolated. The primary disabling method recommended by the manufacturers for passenger vehicles is to shut off the ignition and disconnect the 12-volt DC battery. This shuts down both 12-volt power sources, the 12-volt battery, and the DC to DC converter discussed previously. The simplest method to disable the 12-volt battery is to cut or disconnect the battery cable. Generally, you could cut the negative cable, but there are some exceptions. General Motors places cut tape indicators at the appropriate cut points in their vehicles. Using this procedure should be standard policy on disabling any type of vehicle. A secondary method disables the vehicle in the event the ignition cannot be reached. First, disconnect the 12-volt DC battery. Next, locate the fuse that controls the high voltage system. It will be found in the engine compartment fuse block. And note that that is not a high voltage fuse, it merely provides another means to disable the high voltage system. When pulled, this interrupts current from both 12-volt power sources to relays found in the high voltage battery. This opens a relay, shutting down the high voltage system and effectively disables the vehicle. Simply disconnecting the 12-volt battery alone does not prevent 12-volt current produced by the DC to DC converter from reaching the high voltage relays. If you have difficulty determining which fuse to pull, reference the NFPA EFG or the manufacturer's ERG to identify the correct fuse. If you are unsure which fuse is the correct one, pull all the fuses. Remember, if you haven't shut off the ignition, simply disconnecting the 12-volt DC battery is not enough to shut down the high voltage circuit. The DC to DC converter must still be taken offline as well, which is accomplished by pulling the high voltage system fuse. Likewise, if you just pull the high voltage system fuse, there will still be 12-volt DC power to the airbag and pretensioner systems. To fully disable the vehicle, both steps must be taken. Also keep in mind that after shutting down the high voltage system, vehicles equipped with an inverter converter to drive the electric motors will have capacitors which can take up to 10 minutes to drain down. Remember that the high voltage components and cables can still remain energized until the capacitors fully discharge. This secondary shutdown procedure applies to many of the most common hybrids, but you should always reference the vehicle's ERG or the NFPA EFG to determine the manufacturer's recommended secondary method. For trucks and buses, the primary shutdown procedure is very similar. The first step to disable the high voltage system is to turn off the ignition key and remove it from the vehicle. In most cases, turning off the ignition opens the high voltage relay. The second step is to access and disconnect the 12 or 24-volt DC batteries, depending on the low voltage system. In some cases, there may be a switch in or near the low voltage battery compartment. And if not, responders should double cut or disconnect the negative battery cables. When disabling a 24-volt system, responders must choose the correct cable to cut. While you should choose the negative cable, it may not be as obvious as with 12-volt systems. Do not rely on the positive or negative markings on the top of the battery. Instead, look at the color and termination of the cables. The negative cable will terminate to a chassis ground and will be black in color. Also found on some models is an emergency shutdown feature. This can be as simple as a switch on the dashboard or a knob like this, located outside the battery compartment. With some manufacturers, activating this shutdown is the only way to fully disable the high voltage circuit. Due to the significant amount of variations in shutdown procedures found in commercial vehicles, use the ERG or EFG to determine the exact procedure. In many cases, you will encounter hybrid and electric vehicles that use a proximity key. This allows the vehicle operator to keep the key on their person and not insert it into the traditional ignition key slot. Instead, there is a start-stop button on the dash. If the vehicle detects the key within range, the vehicle can be started by pushing this button. Responders should attempt to locate the proximity key as part of the disabling process. Shut the vehicle down by pushing the power button and then remove any keys from the vehicle so it cannot be accidentally restarted. It is typically recommended to take the key at least 16 feet from the vehicle. However, since these keys can be difficult to find, do not waste valuable time looking for them if they are not quickly accessible. Keep in mind that once the 12-volt DC battery is disconnected, the vehicle cannot be restarted, even if the key is in the vehicle. Proximity keys are not generally found in commercial truck and bus models. Operating the manual service disconnect on the high-voltage battery prevents any current from flowing out of the battery. However, since each manufacturer has its own policies and recommendations on the use of this disconnect by emergency responders and the required PPE, always consult the manufacturer's ERG or NFPA EFG to determine how or if it should be used. Remember that the service disconnect only disables the high voltage system. If it is used, the low voltage battery must still be disconnected in order to disable the airbag and pretensioner systems.